Hi friends, in this video we will see the static VI characteristics of an SCR. So how these characteristics will be. So first let us draw the diagram. First let me draw. This is a thyristor or an SCR. So this is the gate. So here we are providing, this is anode and this is cathode. So here we are providing the voltage passing through anode and cathode. So and one more thing, it is just like it is a switch. So we have to provide one load here. And I want to take a variable variable voltage, so I am providing one potential divider here. So I am getting variable voltage from this. And once this part is over, now I am providing the gate. Of course, this can be connected straight away. So this is the connection. So now here I want to provide one small mechanical switch for giving or removing the gate current. So it is with a variable resistor and a fixed DC voltage. So this is the exact circuit diagram. So now I will write the names also. So this is, I am giving the voltage E here. So DC voltage supply. And this is the load. So this is thyristor. So it is anode and this is cathode. And this is gate. And the voltage across this one is VA, anode to cathode voltage. Current passing through this is IA. Yes, so this is the diagram, how to draw it. And we will see, this is, I can call it as EZ, so voltage across, voltage through gate, and this is also RG, resistance for the gate terminal. So through this EZ and RG, we are providing the current to the gate to cathode. Okay, by providing gate to cathode voltage, we are getting the current passing through that inner P layer. Okay, so this is the concept. So now we will discuss how to draw the VI characteristics. So if you can see the diagram, it is very much clear that anode and cathode are connected to the main source. You can see that this is positive and this is negative. This is positive and this is negative. And here it is positive and negative. So this is a normal thing, and we can reverse it also. Whenever we want, we can reverse it. This is a normal thing, that means it is in forward bias. Okay. So the main connect and gate and cathode are connected, fed from the another source. You can see that is easy. Okay, it is fed from another source, not from the same source. So here what will happen? What is VA? VA is the anode cathode voltage, and current passing through the thyristor or current passing through SCR is IA. So these are very important points. So inputs and different parameters what we are going to discuss. So static V and I characteristics of SCR means voltage across SCR and current passing through SCR. That's all. So these two are the parameters and these two are the supply voltages. So we have discussed these things. So now we need to draw how to draw this VI characteristics. And coming to the discussion, so here the VA characteristics of the thyristor is divided into 3 different regions, and those regions are called reverse blocking region and forward blocking region and forward conduction region. In these regions we will first discuss a reverse blocking region. So what does it mean by reverse blocking region? So here we will draw the diagram also simultaneously. So first region we are discussing here is reverse blocking region. So reverse blocking region means here cathode is connected to positive terminal and anode is connected to negative terminal. So it will be reversed. So it is minus and it is plus, reverse. So in this case what will happen? Okay, I can write like this. This is minus terminal and this is plus terminal. Okay, of course this can be reversed. Okay, this is minus and this is plus. Okay, then tell me what will happen. Because of these two, here it is PN structure will be there. We have seen in the last video also. Because of PN structure, J1 and J2 are in reverse bias now. J1 and J3 are reverse biased. And J2 is in forward bias. So here we made S2 open. Okay, S is a switch here. So this switch is called S. So we are not making it close. So we are simply opening it. That means we are not giving any gate voltage through the gate cathode terminals. Okay, so this is the structure of reverse blocking region. So in this region what happened, it is just like a diode only. So now what will happen means J1 and J3 are in reverse bias, J2 is in forward bias. Therefore what will happen, a small leakage current flows through it because it is having reverse biased junctions. So what will happen? If the reverse voltage is increased, okay, if we increase the reverse voltage, there is a critical breakdown voltage VBR, okay, which is an avalanche voltage for both J1 and J3. Okay, so it increases the current sharply. So if you reach that level, it increases the current sharply. So that's why what will happen, if the current is not limited to a safe value, for example we are unable to limit this current, what will happen, power dissipation will increase to a dangerous level. Okay, that will damage your device because two reverse bias condition suddenly they are breaking down. So there is a huge current flow through the device, so it will be destroyed. So what will happen, what exactly happens? So here and the next region is forward blocking region. So second one is forward blocking region. So in forward blocking region, this is connected to positive and this is connected to negative. This is positive and this is negative. Okay, then what will happen? Then what will happen, in this anode is connected to positive supply and cathode is connected to negative supply. Again switch S is open. Okay, till now we are not touching the switch S. So junction J1 and junction J3 are in forward bias and junction J2 is in reverse bias. So as J2 is in reverse bias, so again we need to provide more and more voltage. So very small leakage current is flowing with the normal voltage conditions. So this is also, it doesn't conduct. Okay, now we need to move on to the forward conduction region. So how it will be? So for this I want to draw the circuit diagram. So now I am drawing the characteristics. Please observe, this is VA. So it is positive in nature. I mean it is VA positive. So this part is VA negative. And the above part is current IA, positive part, and it is IA, negative part. Okay, this is in volts, this is in amperes. So in reverse region, it will be like this. So a small leakage current flows. This is a very small leakage current. So at this stage, so this point is called VBR. So at this stage, it is turning off. Okay, it is turning off. So avalanche breakdown happens. So this part we will see. This is forward break. Sorry, this is reverse blocking region. Coming to forward blocking region, so it is also up to this level. After that, it will be coming to conduction. Okay, after this, it will be coming to conduction, and this will happen at VBO, and we'll see that part. And suddenly, current will rise. There is a sudden current rise at IL. I will see. So let us draw the diagram. So this is current axis. And this is voltage axis. So this is VA, voltage across thyristor, positive side, and this is VA in negative side. So this is IA, current in positive side, so measured in amperes. So this is measured in volts, and this one is IA minus. Okay, now we will see how this reverse blocking region, forward blocking region, and also forward conduction region will appear. So it is like this. For reverse blocking region, so very small leakage current will flow up to VBR. So after VBR, so this point is VBR. After VBR, there is a huge current flow through the device. Okay, and coming to this part, in forward blocking region also, it is blocked up to VBO. After that, what will happen? We will see here. So, in forward conduction region, if S is still in open condition, we have to provide voltage greater than VBO, forward breakover voltage, then only the device will conduct. So what will happen if the device conducts? The device conducts means a sudden decrease in voltage will come, and later a sudden increase in current. Okay, so this is the concept. So this part is VBO. Okay, let me write. This is called VBR. This is VBO, breakover voltage. Okay, now what will happen if SC is closed? Suddenly if I can give gate pulse also, then what will happen? Because of this gate current, my device will conduct before VBO. That means, for example, if I provide small amount of current IZ1, the device will start conducting before VBO at voltage V1. Similarly, if I increase the current, what is the purpose of this current? This gate current purpose is we want to make our device to turn on before the breakover voltage. That means we are going to decrease the voltages, breakover voltage or anode voltage, anode to cathode voltage, or voltage across the thyristor. So that's why whenever you are increasing IZ1, to IZ2, your voltage will be reducing. Similarly, if I further reduce it to IZ3, so the voltage will be further reducing. So that's why this is called, so if IZ3 is more than IZ2, which is more than IZ1, what will happen? I can apply less V3 compared to V2 compared to V1. This is the concept. Okay. Now let us identify different regions. So what are the different regions in it? So let me start with 0 here. So this is 0. In forward breakover voltage, it is up to M. So this is called forward blocking region. Forward blocking region. In forward blocking region, there is a small current called, this is small current, and this current is forward leakage current. Forward leakage current. Okay, this is regarding the second point. Okay, forward blocking region. In forward blocking region, small current called forward leakage current is flowing through the device. And coming to reverse blocking region, so this is the reverse blocking region. So let me write P here. OP is the reverse blocking region. Reverse blocking region. This one, and there is a reverse leakage current flows while it is blocking. So this is called reverse leakage current. And from P to, let me take point Q. From P to Q, this is called reverse avalanche region. So reverse avalanche region, when reverse breakdown completely happened. Okay, and coming to this point, so I forgot to tell you one thing. So whenever we are applying without switch S is, when switch S is open, so without giving the gate current, we are applying VBO so that it will be turned on. So it will be turned on at current called latching current IL. Latching current IL. Now, if I want to reduce, if I want to make this device to unconduct, or if I want to make this device to block, and I want to bring down to blocking state, or I want to switch off the SCR, how can I do that? So to switch off the SCR, I am at this spot, I need to reduce the current up to latching current. If I leave here as it is latching current, so again it will be turned on. So what will happen? I need to reduce this current below the latching current called holding current. This is called IH. Okay, so after this, if I leave the device like that, it never go back to conduction state. It will be still off only. Okay, so this current is called holding current, and this is very important. My latching current is always more than holding current. Okay, so now the things, so as we know, this is the way at Iz equal to 0. So once this part is over, so Mn, the region Mn, this is M and this is N. So Mn region is called, that is conduction. Yes, so the region Mn shows, so whenever the thyristor latches into the conduction, so it is ready to conduct. Okay, so this is the part. So it is struggling part actually. So the huge several hundreds of voltages are converted into small 1 or 2 voltages, and huge current will pass through this. So after N there is a K. So NK region is called forward conducting region. So this is called forward conduction region. So this is this part. So these are the different regions of VI characteristics of an SCR. Okay, only 3 regions. First one is a reverse blocking region, forward blocking region, and forward conduction region. In reverse blocking region, we are having a reverse leakage current. In forward blocking region, we are having forward leakage current. In forward conduction region, we are having complete current. So this is how we need to explain the static VI characteristics of an SCR. Okay, so the advantage of SC is closed is we have discussed here. You can simply observe here. You can write these points here only. That's all. Then this will be completed. Yeah, if you have any more doubts, you can put it in the comment window, or you can put it in the comment window so that I can see it and I can give the answer within 24 hours. Thank you so much for your careful listening, and please like this video, share this video, and subscribe to my YouTube channel. Thank you so much.